Welcome to the 4DSTEM Mega Navigator, a high-performance platform for loading, visualizing, calibrating, processing, and analyzing four-dimensional STEM datasets. In this tutorial, we will go from raw detector files all the way to advanced diffraction analysis, virtual imaging, strain workflows, and DPC processing. Before we start with the actual software, a few words about the concept of 4DSTEM. In conventional STEM, each scan position produces one detector intensity. In 4DSTEM, we record a full diffraction pattern at every position. This creates a four-dimensional dataset, two real space scan dimensions and two reciprocal space diffraction dimensions. This enables virtual imaging, strain mapping, orientational mapping, differential phase contrast, trichography, electric field reconstruction, and crystallographic analysis. To follow properly the tutorial, I suggest that you download the software to your local computer. You don't need to install it. Just extract the zip file and run it on your local computer. To download the software, you can go to this website. And at this website, you have a link here to download the latest version of the software. And this is a link for the manual, a PDF file. You can read there also about the physics behind the various analysis. It's not always the most updated, but you can use it also. To download the file, just go to the Dropbox link here. You can download the software, which is in a zip file. It's quite large, but you can download it to your local computer and unzip it and just run the exe file. You can also download these example block files and synthetic datasets in order to learn and see how the software works. After downloading the software, you can run it by clicking the exit file, and you can also produce a shortcut. The first time you run it, it might take a while to open the software. But eventually, you'll get this window. Now we can open a file. Click on Open. We can choose various types of files including ZAR folders or files, NumPy files, and Nanomegas block files. We can also load Dectris H5 files by choosing the master.h5 files. For quantum detectors Merlin MIB files, and for Thermo Fisher MRC files, we need to convert them first to ZAR folders using the File Converters tab, and then we can upload them as ZAR folders. ZAR file or ZAR folders are special formats that are extensively used in the big data community. They are very efficient and fast for lazy loading. As an example, if we want to load a block file, we can go to the example block files that can be downloaded from the same Dropbox folder where the software zip file was downloaded. You can see there's a progress bar for loading the file, and one for rebuilding the navigator based on the diffraction patterns. If we want to load a ZAR folder, instead of choosing a file here, we click on Cancel, and then we can choose a folder. For the Files Converters, we can use this tab. This allows us to convert MIB files datasets from the Merlin quantum detector to ZAR folders, and also from Thermo Fisher Velox MRC file datasets. Once the dataset is loaded, we can use the various tabs to analyze our dataset. Now I will explain a little bit about the different features and how the GUI is structured, so you can use it easily. Here at the top we have the opening of the files and rebuilding the navigator. Down below we have different buttons that I will explain a little bit later, which are general features for all types of analysis. And we have the various tabs here that we can choose according to the analysis we want to do. For each tab, we have this area with a control that changes according to the specific tab we are using. And below it, we have the area with the navigator and the diffraction pattern. The diffraction pattern shows the corresponding diffraction pattern according to the locations in the navigator. We can also select an area in the navigator to get an average diffraction pattern of the selected region. If we are standing with a mouse on the navigator and we move the mouse wheel, we can zoom in and zoom out. Exactly the same also on the diffraction pattern. By right-clicking, we can reset both the navigator and the diffraction pattern. If we want, we can change the color map of the navigator by choosing the different color maps available. Choosing the right color map really depends on the type of analysis that we want to do. Sometimes we see better features using different color maps. And we can do exactly the same also on the diffraction pattern. And we can also invert the images, both for the diffraction and the navigator. Next, if we know the pixel size calibration values, we can enter them manually. The background is white as long as there is no calibration. Once we change the calibration, it becomes green. Please note that if the diffraction pattern is calibrated, the inner and outer radius of the virtual apertures will appear in millirad instead of pixel. Later, we will see a tool that helps calibrate both the navigator and the diffraction pattern. Since right now it's not calibrated, we will put the values back for both to 0. And the last option here is to save the navigator image and also the diffraction patterns with and without the overlays which are on the diffraction pattern or on the navigator. If we want to calibrate the images, now what we can do is go to the Filters and Line Profiles. In the Filters and Line Profiles, we can choose to draw or edit a navigation line, a profile line on the navigator or on the diffraction pattern. So if we choose the diffraction pattern and we draw a line here, we get a window with an intensity profile along this line. We can change the width of this line by changing the average width. And we can also choose a range in profile. We see that this range is shown over here. And if we know this distance, in this case, this is in a reciprocal space, so the distance represents a D spacing. So for example, if we decide that this is 3 angstroms and we apply calibration, then you can see that now our diffraction pattern is calibrated in units of 1/nanometer per pixel. We can also do exactly the same also on the navigator. We can choose distance like this if we want. We can also here have an average width. And if we decide that this range, this distance is, for example, 100 nanometers, so we write here 100 nanometers and apply the calibration, then you can see that the image has a scale bar. It also shows here the nanometer per pixel and it's green. If we want to save the calibration for the navigator and the diffraction, we can click on this button Save NAV DP Calibration. It will save it to the ZA attributes file, which is in the same folder of the data. Thank you for following this part of the tutorial.